What's up, everybody? This is Danny Mathematics here with another example to explore. And today, guys, I want to go over finding the volume of 3D shapes, okay? In these next series of examples, guys, we're going to be finding the volume of 3D shapes, okay? And there are two different types of 3D categories or 3D shape categories, right? You have prisms, right? And then you have pyramids. You have prisms and you have pyramids. Today, guys, in these next few examples, I'm going to focus on prisms. Okay, so the difference between prisms and pyramids, right? If you know what a pyramid is, guys, pyramid, think about Egypt, right? Think about the pyramids in Egypt. The pyramids look like this, and there's only one base, okay? The base is basically the part of the 3D shape where the 3D can stand, okay? So if I was to flip the pyramids upside down, the pyramid would tumble over because it only has one base or one foundation. With prisms, have two bases, right? And for example, this is an example of a prism, okay? Which is a cylinder. It has a circular base up here at the top, and it has a circular base at the bottom, right? Meaning that if I was to flip it on its head, it would still stand up, right? Or I would flip it to where the bottom is at the bottom base at the bottom, it will still stand. So having two bases mean that I can either stand straight up or I can stand upside down, right? I still will stand up straight. So that's the difference between pyramids and prisms. Prisms have two bases, while pyramids only have one base, okay? So here are just examples of prisms that you will see, right? You will definitely see a triangular prism, right? Because it has two triangular bases, a top base and a bottom base. And once again, it can stand on either base. If I was to prop it up on the bottom base, it can stand up. If I was to prop it up on the top base, it will still stand up the exact same way. The same thing with a rectangular prism. It has two rectangular bases. A cylinder has two circular bases. And then this is just another example of a triangular prism with two triangular bases. And triangular prisms can come in different, they can look different because there are different types of triangles, okay? But essentially, they're all the same, all right? So let me go over the formula, guys. Finding the volume, right? Volume is when you are filling something up within itself, right? That's 3D. So for example, imagine you turn on your bath water and then you forgot that the bath water is running, and then when you came back, the water was filled all the way up to the top of the tub to where it's about to spill over. That's volume because we spilt the tub all the way to its max, right? We filled the inside of the tub to its max. Another example, this cylinder. If I was to fill this whole cylinder, right, this cylinder container with Skittles, right, all the way up to the top to where I can barely close it with the top base, right? That is volume because I'm filling it up fully with Skittles, okay? So that is volume. How much a 3D shape can be filled within, right? How much you can put inside of a 3D shape, okay? So the formula to find volume, guys, is V, which is volume, equals big B, which is the area of the base, times the height of the whole prism, or the height of the whole 3D shape, okay? So once again, V equals big B, which is the area of the base, times the height of the whole 3D prism, okay? So remember, guys, big B, right, is the area of the base. So depending on the base, guys, or the shape of the base, big B is going to turn into the area formula of that shape. So if the shape of the base is a rectangle, big B is going to turn into the area formula of a rectangle, which is really A equals base times height. But in this situation, we're going to say big B equals base times height. The same thing with triangles, right? The area formula of a triangle is base times height divided by 2. And then the same thing with circles. If the base is a circle, it's going to change to the area formula of a circle, which is pi times the radius to the second power, okay? So that's essentially how we would find the area of the base, which is big B. And remember, guys, the height of the whole thing, or the height of the prism, is the height of the whole prism, right? Or the distance between both bases, because one base is the top, one base is the bottom. So I just wanted to go over just a quick update on the notes that we need in order for us to understand volumes in 3D shapes, okay? So in this particular example, guys, I have this particular 3D shape, or this 3D prism. I know it's a prism because it has two bases. So let me go ahead and label those, okay? It has two bases. So I'm gonna go ahead and label them. So I have a base right here, Okay, and I'm just gonna say this is the top base, and once again, they're interchangeable because the top can essentially be the bottom base, right? Okay, and then this is a base right here, and we're just gonna say the bottom base, right? Okay, cool. So we have two bases, right? So we know that we're a prism, and then both bases are shaped as triangles, okay? Both bases are shaped as triangles, so I know that I have a triangular prism, right? We have a triangular prism. Now, they want us to find the volume. So let's go ahead and write out the volume formula real quick. Okay, the volume formula of all prisms is V, which is volume, right? And once again, this is for all prisms. All right, equals big B, which is the area of the base, or the two bases, times the height of the whole prism. The height of the whole prism, okay? Just the area of the base, right, which is big B times the height of the whole thing, right? Now, what we need to do is, guys, we need to solve for big B, okay? We need to solve for big B. And as you can see, guys, the bases, which is big B, are shaped as triangles, okay? They are shaped as triangles. I'm just gonna draw a triangle underneath, okay? They are shaped as triangles, right? So I know that big B has to turn into the area formula of a triangle. It has to turn into the area formula of a triangle. And the area formula of a triangle is base times height divided by 2. So small b is just the length of the base, right? Big B represents the area of the base, all right? So I just want to point out that difference. So it's going to be small b times the height of the triangular base divided by 2. So once again, it is the base of the triangular base, right, times the height of the triangular base divided by 2, okay? So let's go ahead and do that, guys. Let's go ahead and do that. So as we can see, guys, I'm just drawing the base over here, okay? So as we can see, guys, the base segment or the base side of this triangular base is 6. So small b equals 6, right? The height of the triangular base, as you can see, is 7. So small h is 7. And then all we have to do is do 6 times 7 divided by 2. So let's go ahead and do that. Divided by 2. 6 times 7 is 42. Divided by 2 is 21. It's 21. It's 21. Okay? So big B, the area of the triangular bases is 21 square feet, right? It's 21 square feet. But remember, guys, that is not our final answer. That's just the volume of the triangular bases, right? So let's just act like if the triangular bases, we only had the triangular bases, then it would be flat 2D. We just only look for the volume. But we have two triangular bases, and we have all of this inside part that we have to fill, right? Which represents area. So now we're about to find out the area, guys. We're gonna plug in 21 square feet in as big B. So big B equals 21 square feet. All right, times the height of the whole thing, right? The height of the whole prism, which is basically the distance between both bases, okay? The distance between both bases is 21 feet, right? So that will be the height, right? It's 21 feet. So it's gonna be 21 square feet times 21 feet will give us the volume, okay? So essentially, guys, we have 21 times 21, 21 times 21, which equals 441, 441, guys. So the volume is 441 cubic feet, right? That's feet to the third power, cubic feet. That means that we're filling it in, guys. That means that we're filling something in, which is finding the volume. Okay? So for example, guys, if we had this, guys, and these were some real dimensions, and we was to fill this prism up with Skittles, right? Then we can fill it up at 441 cubic feet of Skittles can be filled up within this particular triangular prism, or whatever you're putting inside, right? It has a volume of 441 cubic feet, okay? So this right here is the volume. All right? So once again, guys, this is how we find the volume of prisms, okay? Remember, guys, big B is the area formula, right? That's representing the shape of the base, okay? So if the base is a triangle, big B is going to turn into the area form of a triangle. If the base of the triangle, if the base of the prism is a rectangle, this is going to turn into the area form of a rectangle. If the base of the prism is a circle, which makes it be a cylinder, then it's going to turn into an area form of a circle, right? So remember that, guys. Big B is interchangeable depending on the shape of the bases, all right? Thank y'all so much, guys, for tuning in. I will come out with a few more examples going over prisms. Thank you.